welcome to everybody who is just joining us. Welcome to the Post-Construction Plan Review 101 workshop. Welcome to Stormwater Awareness Week. We have a great workshop planned for you today. Colleen, if you would like to introduce yourself, I'll hand the workshop over to you.
Great, yeah. Thank you. So my name is Colleen Hunt with Stone Creek Environmental Consulting. I am located in Windsor, California, which is about 60 miles north of San Francisco. I have 25 years experience in water quality regulation, including working as a regulator for 18 years for the state of California. And I've been a consultant for the past 7 years. So thanks for joining us today. I have a certain passion when it comes to post-construction and really making these requirements very viable. We put a lot of resources into post-construction, and I think that it's a really important element to our programs for water quality benefit. So I'm very happy to be here to provide this workshop today. So as it says in the title of the workshop, this is Post-Construction Plan Review 101. So it's really going back to basics, not necessarily intended for, it's a broad audience, right? So my intention is to really review some kind of fundamental areas for plan review. And so looking at some things from an elementary standpoint. So if you're new to plan review, this will be a great workshop for you. If you're a seasoned plan reviewer, and you could probably teach this workshop better than me, I hope that it at least brings you some maybe tips and tricks or things to think about, or just a refresher on an approach for post-construction plan review. This training is really intended for those who are responsible for plan review, not engineering of LID design or post-construction design. I am not an engineer, and so I'm not teaching how to design or to review plans to QA/QC an engineer's work. And I think there's lots of different philosophies on this. I have some clients who, they do that level of detailed plan review because the city engineer is reviewing these plans. Other clients of mine, the LID plan review or post-construction plan review is done at the planning and building department. And so it's people who don't have a background in engineering. And so, this is really intended to be a little bit broader than for engineers who are doing design. And I also put like a streamlined approach to plan review. I think we're all so busy and we have so much work and we're understaffed. And so how can we kind of streamline some of our processes to get to the finish line in a little bit simpler manner? So let's start with plan review objectives. And really, the plan review objective is to determine if your plan's consistent with permit requirements. So we're speaking to those requirements in a municipal stormwater permit that mandate how post-construction requirements should be met. And most MS4 permits have evolved that post-construction requirements need to be met through low impact development. And I'm going to talk about terms and definitions here in the next couple of slides. But ultimately, as a plan reviewer, what we're trying to accomplish is, if you represent a municipal stormwater permit holder, you want to review these plans to make sure that those requirements, which, essentially are pass-through requirements onto a development, that they're being met, because you have an obligation as a municipal stormwater program permit holder to make sure projects meet the requirements of your permit. And really what that comes down to is, does the plan meet the treatment or the retention design storm using some type of best management practice, whether, there's different terminology. Is it whether you're using site design measures, which I'll define, or bioretention, is the plan, does it accomplish what your permit is intending? And that's the treatment or retention of a certain amount of water. Because of the broad audience here today, I got a statistic before we started that people from over 46 states have registered for various workshops. And so because of the broad audience, this training, I can't get into specifics for permits. So we're not really talking about permit requirements or what triggers low impact development or, different types of specifics, your design criteria or your design storm or those types of things. So this is really more about having a plan in front of you that you can review. If you have to know those requirements, right? I can't review that or go over that today, too broad of an audience, but we can apply some fundamental practices in plan review, regardless of the requirements that are out there. So I think those are all my disclosures. I think if you just know, a takeaway is broad audience, and so it's a broad training. I like to start out all my trainings with reviewing terms and definitions. I think that as these requirements have evolved, there are some terms that are used interchangeably, and they have maybe subtle differences, but they do have differences. And as a plan reviewer, I'm kind of a stickler for these differences. I'll kick a plan back to the designer if they're not using the terms in the right manner. I also feel like when you're doing a training, we all need to be on the same page about what these different terms mean. So post-construction is a very broad term that really refers to the implementation of control measures to reduce the discharge of pollutants from the municipal separate storm sewer system, which receives discharges from new areas of new development and redevelopment projects, which is basically just to say that post-construction is looking at controlling pollutants in a development or a redevelopment project using some type of best management practice. So this is broad, right? And we're going to talk about the definition of low impact development next, but post-construction could refer to a variety of different BMPs, best management practices. This could be an oil water separator, which is not LID. It could be other implementation measures like labeling storm drains with a medallion that says, drains to a creek or the ocean, right? So very broad, some type of BMP to reduce pollutants and stormwater runoff. And as I said earlier, a lot of these requirements, at least in the state of California, I'm not sure about other states, they have evolved to require low impact development. And so this is the concept of, that natural, kind of trying to maintain that natural hydrology, treating pollutants with landscape-based BMPs with the goals of capturing, treating, infiltrating, filtering, storing, evaporating, or retaining runoff from a given storm event. And different permits have different requirements. I know I work with some permits where there's a retention requirement. And so you have to design your BMPs to retain a certain amount of water. Others are treatment based or some type of combination. So LID, particularly, we're going to be focused on bioretention today, can accomplish a variety of these requirements, but ultimately bioretention is usually selected for retaining a certain amount of water during a particular storm event. This is not LAD. I see this a lot, and while this has post-construction, this can be considered a post-construction BMP where water is directed into this, I'm going to call this an infiltration basin. And it retains, but it doesn't have that vegetative component. And so it lacks certain characteristics that we expect for low impact development, particularly bioretention, right? And so there may be conditions where this is allowable, but we're looking at that vegetated state as part of the treatment component. And so trying to gear away from these rock infiltration BMPs and moving towards true bioretention. MS4, Municipal Separate Storm Sewer System. Just want to define the acronym that, this is referencing municipalities who have stormwater infrastructure that drains directly to some type of water body. It does not go to their wastewater treatment plant. And so therefore the water is discharged without first being treated unless there's a BMP. Receiving water, I may refer to receiving water, which is basically where the storm water is discharged to. Retention versus detention. I do see these terms used interchangeably, and there is some subtle differences. With a retention basin or a retention requirement, we're really looking at holding water on site, a certain volume of water, and designing a BMP that will retain that amount of water on site. And then whatever's retained there, therefore doesn't discharge to the MS4 or receiving water. Detention, on the other hand, really like that classic definition of detention, is a temporarily holding water. We generally have detention basins to hold large storm events to avoid flooding of a given area. Detention basins, like this one in the picture, this is concrete lined. So there is no infiltration into the ground. There is no retention component. The water here is held temporarily, and then it is released back out into the environment. So there is very little treatment. You could make an argument, I think large particles may settle out to the bottom, but you're not treating pesticides or inorganics or metals through a detention basin. And there really is no retention component to, like I said, a classic detention basin. I think we've evolved. Some detention basins are being developed with low impact development in mind so that they're not concrete lined. And so, whether we call that a detention or a retention basin, maybe it depends on the actual purpose that it's designed for. But in LID, I get plans sometimes that say, well, we're going to put a detention basin in as our BMP. And I work with permits that prohibit detention basins for LID compliance. And so then it's like, well, do you really mean retention? Or otherwise I'm going to have to kick back your design because you're not going to meet the requirements of the permit. And then bioretention. So as I mentioned, I'm going to kind of focus on bioretention today. It's kind of the LID standard to meet particularly those retention requirements. And so we want to make sure that we understand the difference between bioretention and some other terms that are out there related to treatment. So this is to retain stormwater runoff using vegetated depressions and soils. Whereas like biotreatment or biofiltration, that is more of a pass-through system where there is no retention, that you get treatment through your engineered fill and your vegetation, but then the water drains through, like we can see on this tree well, and is discharged with very little retention. These aren't designed for retention. So again, I see these terms all used interchangeably, and so just want to make sure we're on the same page on kind of what these different terms mean. Then there's a bioswale, which is technically can be designed as bioretention, but it usually refers to something in like a linear path, your BMP. And you could have a bioswale that doesn't meet a retention requirement. So you kind of have to just really have a design standard so you understand what the BMP is accomplishing. And then finally, we have rain gardens. In some of the LID manuals or design standards I work with, rain gardens really have a bioretention component. They have the engineered fill, they have the vegetation, but they're usually very small scale. And so looking at draining like less than an acre of impervious and having these more small scale designs. So you can see some of these things that it's a fine line between these different terms. But I reviewed a plan once where they had used the rain garden design standard for a tributary area that was over 7 acres. And so it doesn't match up, right? So what they really had was bioretention, but they had submitted the rain garden design standard. So again, I'm a stickler for terms and really saying like, really having an understanding of what are you proposing? What does this really, what is the real requirement and objective? So something to keep in mind when you're reviewing plans. Okay, so that gets us through some of the terminology, some of the, I gave you all my disclosures. But with that being said, as we move forward with this workshop, I kind of had to have some point of reference for plan review to give information that makes sense. So I'm basing the remainder of the presentation off of the requirements within the state of California's small MS4 permit. So this is a general permit that is available to municipalities that are under 100,000 in population and are not required to enroll in an individual permit, which there are a lot of small municipalities in California that are in, well, I shouldn't say individual, but regional permits. So, essentially we have requirements in our permit to have LID conditioned on development and redevelopment projects. Most municipalities put together some type of manual to present to the regulated community what the expectations are in terms of project design. And so in this particular example, what needs to be submitted is a stormwater control plan that details how this project is going to meet the LID manual and ultimately the permit requirements. And there's essentially 4 components to the stormwater control plan. So there's a checklist that says, here's all the things you need in order to provide a complete submittal to the municipality. We want to see drainage management areas, and I'm going to get into each of these in a little bit more detail. Site design measures and your numeric sizing criteria. So we'll kind of break that down as we move through the training. So, the first thing that I think is really important is, do you have, as a plan reviewer, some type of submittal checklist? Something that guides you to know whether or not they have a complete package, that they've submitted a complete package. Doesn't mean it has to have, doesn't mean that their package can be approved just because they have every component, but some type of guidance for you as a plan reviewer to go through and cross-reference to make sure that they have everything they need before have everything that's required before you start to review. I know I work with some permits where this is a requirement. And so the MS4 permittee could actually be audited by the state regulator, and they could ask, I would like to see your plan review checklist, and that they have to provide that checklist to demonstrate compliance with the permit. So you may be mandated to have this. And even if you're not, it's a good idea. And there's lots of references and resources out there to kind of help you if you don't have one and you are mandated to do these plan reviews. You should look into finding something that can help you. So what I do for plan review is the first two things I do is I look to see if they've submitted all the components, and then I do a quick review, right? I don't take any notes. I'm not making any notations about whether they've met requirements or not. I just want to know, what is the project about and what is the proposal to meet post-construction requirements. So those are kind of the first two things that I do. And then with the submittal checklist, if there are things missing, I think you have to decide as a plan reviewer, do you want to kick it back at that point and say, okay, I can't review this until you've provided all these components? Or do you want to do some review and give them all the comments at once and saying, you can maybe streamline things a little bit for the project by doing it that way, but it's up to you on, whether or not you want to review the whole package at once, or knowing you're going to have to kick it back regardless of your other comments. And then when we review, we're really asking ourselves, like, does this plan make sense? And I'll define site design measures in a few slides. So I apologize if that's a term not familiar to you, but it's essentially BMPs that allow for crediting to reduce impervious surface that's calculated towards your volume of water that either needs to be treated or retained. The drainage management areas, or DMAs, really looking at, I'm a big component of this is, do all aspects of the project that are required to treat or retain stormwater, are they part of a DMA? Does each DMA drain to a single point? I've reviewed a lot of projects where you've got like 3 DMAs, but then they all seem to go to one BMP, or vice versa. I'll get a project that just says the whole thing is one DMA, but then there's 3 BMPs. And so, really kind of looking at, does it make sense of how the DMAs are delineated and going to a single point? If they're using bioretention, or whatever the end BMP is for treatment or retention, can you find those on a map? Like, is it clear what is being proposed? And then again, I'm kind of big on this, are the terms used correctly and consistently? So it's kind of a high level review on what you could be looking at in terms of these plans. So here is a plan, and could I get a thumbs up if you could see my cursor? I don't know if that translates. Okay, thank you. So this is what I'm going to do today, to kind of show you, to walk through a plan review is an example project. And so this is an In-N-Out Burger. And for those of you from the West Coast, this is kind of an iconic burger restaurant, fast food restaurant in the West Coast. Anyway, so we have their site plan. We have, let's see, 1, 2, 3, 4, 5 drainage management areas. And we have some good information here on their size, the amount of impervious surface versus pervious surface, which help us understand the calculations in terms of the volume of water that's directed to a BMP. So to orient you on this map, we have a BMP located here and here. So we have, 5 drainage management areas with 2 BMPs. So as I'm reviewing this, I'm going to go, okay, I have questions about that. And let's see if maybe through my plan review, those questions are answered. The drainage management areas, I do have a map that kind of distinguishes those drainage management areas a little bit better. But we have A, which is a parking lot, half of the building, and maybe 3/4 of the drive-through. We have B, which is the other half of the building and the other half of the drive-through. Then we have C1 and C2, which are very small components to this plan. And then we have D, which is also a very small area. That also happens to be basically all pervious surface, very small amount of impervious surface. So just a little bit about this project is this is a redevelopment. So this was a demolition of an existing building, and they're going to construct a 3,867 square foot restaurant with a drive-through lane, parking, and landscape. The project size is about 1.35 acres. The area of new or replaced impervious is 1.05 acres, and the area of pervious is 0.30 acres. So again, we've got our 5 drainage management areas. Here's a little, color coded where I highlighted the BMPs. So I've got A and B drain to BMPs, C1, C2, and D do not drain to BMPs. So their BMPs are provided in a chart in terms of some specific information that's required, which includes the drainage management area square footage, the runoff factor. So this is used to calculate the volume of water that needs to be, in this example, retained. The minimum facility size. So this refers to the BMP's square footage in order to meet the volume retention requirement. And then the actual size. So they're oversizing 2 of their BMPs. So as I go through and review this project, I'm going to make some notes. So my first note is going to be 5 drainage management areas, but only 2 draining to bioretention. So what are we doing with the other 3? And I'll note that the oversized BMPs, those are a red flag. And while, this is going to be kind of permit specific, oftentimes you can oversize BMPs for retention purposes. You may not be able to retain the appropriate volume of water for every drainage management area, but all runoffs usually still needs to be treated. So when we think about those C1, C2, and D areas, looking at, well, is there still a treatment component, even if you've oversized other BMPs, so you're retaining a volume of water relative to the whole project, we still need to treat all of our runoff. So that's something I'm going to think about while I'm working through this review. Okay, site design measures. Probably should have defined these earlier in the training, but these are usually credits that are given to a project to reduce the volume of water that needs to be treated or retained. And I'm going to give you an example, but the types of site design measures we see can be stream setbacks and buffers, soil quality improvement, tree planting. The most common is disconnected impervious pavement, so like a roof disconnection. So instead of plumbing the roof runoff to a pipe that ultimately carries that runoff to a storm drain, it's somehow retained on site. And if you can retain that on site in a vegetated area, you can take that amount of impervious surface and subtract it from your overall calculations of the volume of water that you are required to retain. So most MS4 permits, at least in the state of California, have some type of crediting system to encourage these types of practices in development. So I'll go through a quick example. Let's say you have a project and you have 500 square feet of impervious surface. Normal circumstances, you would have a pipe that sends that out to offsite to a storm drain. Let's say instead you send that water or some percentage of the water, it's not an all or nothing, that you create a depressed vegetated area that can hold a certain amount of water. Now you can direct that to this area, and whatever percent of this square feet that is directed to the landscaped area can then be provided as a credit to reduce the amount of water you have to retain with bioretention. So if you don't have this crediting system as part of your program or permit, you can kind of disregard this, but I think because most in California do, I wanted to include this as something that we look at. And so for this project, the narrative talked about a rooftop and impervious area disconnection. And so that they were going to direct some percentage of their rooftop runoff to a depressed vegetated area. So separate than bioretention, right? So that they were going to divert, if you will, their roof runoff to somewhere else on the facility to prevent it from going to the storm drain system without having it to be part of the sizing calculation for the bioretention. But then when I looked at this is a table in the template for the stormwater control plan where you put in your credits. And so you basically put in like, okay, in this drainage management area, we're going to take this much rooftop impervious and direct it to this landscape area. Well, you can see this is blank and this wasn't the template. This was their actual plans. And so they didn't take the credit. And that's okay. You read in the narrative that they were going to take a credit and then you don't have that credit calculated. Something to note, like it's something that I noted where it's like, what did you mean to take the credit? It's the design, it's the advantage of the project to take those credits. I wouldn't necessarily not approve a plan that had this, said they were going to take a credit, but then didn't. But there's an inconsistency there. And sometimes I think what happens is that's the intent. So the narrative gets written. And then when the actual design occurs, they're like, well, we can't do that because we can't get that depressed area to meet the requirements for how these site design measures have to be designed. So we'll ditch that. And then they forget to update the narrative, maybe. But just, the overall point is looking at, if you do have a crediting system, making sure that you look at that and that it's accounted for appropriately based on whatever site design measure they've selected. So I'm just going to add to my notes that they selected the impervious area disconnect, but didn't include the credit. I might not say anything about that, but I'm just going to note it. Okay, now we're going to look. So we've looked at the drainage management areas where we're trying to see, do they drain to a single point? Do they drain to a BMP, a bioretention? Do we have a good grasp on the treatment or retention, how they're meeting those requirements, right? So we're not looking at the engineering calculations. We're just looking at in their narrative and on their maps, can we determine that they're accounting for the treatment and the runoff retention that's required? Do they have the BMPs? Does it make sense? Okay. Now, the other thing I do in a design review is look at water in, water into the BMP, water out of the BMP, and I do look at the overflow bypass elevation. Now, that might be going against what I said about I'm not double checking an engineer's work. And I'm going to show you some examples of why I look at the elevation of the overflow bypass. But essentially, I'm not looking at the elevation to determine if it's enough difference between the lowest point of the BMP and that bypass elevation. I just want to make sure that the bypass elevation isn't the lowest point in the BMP, which I see more often than not. And I think that's evolved a lot as these requirements, when they were new requirements. I think the concept of stormwater drainage is you put your stormwater goes to the lowest elevation at the project, right? Water flows downhill. And so I think it took a shift to get these overflow bypasses to an elevation that was above the bottom of the bioretention in order to get that retention requirement met. So I'm going to show you some examples of where these requirements weren't necessarily met. And so becomes an issue because once it's installed, we don't want to fix it then. We want to fix it. We want to make sure we stay ahead of this. And so what I told some of my clients is I would rather have the conversation up front about during the planning, than to go to a project when everything's installed and say, well, you really didn't do this correctly, right? So trying to get ahead of that conversation. Okay, so, in the interest of time, I'm really going to fly through these photos. To be honest with you, doing this type of training in an hour is really challenging. I mean, LID in itself could be like a semester class at a university. So there's just so much to talk about, and to condense it all into an hour is really challenging. So I'm going to move through these slides quickly, but you can see they're going to start to have some repetitive themes. So we have our, the water is going in to the BMP, but then there is an outlet right where the water flows. So there's no retention, there's no treatment. This is just, I'll use the word fail. That seems very harsh, but it's not good, not a good design. So this is why I like to look at the plans to say, okay, what's the configuration here? Because we need to avoid this, because I see this a lot. This project, there was supposed to be a curb cut here. And so this BMP was supposed to receive water from like half of this parking lot. And, whether this was an install fail or a design fail, I'm not sure, but just showing examples of, we really need to know how the water is going to get into these BMPs. It's really important. to make sure that we have this as an understanding. Again, rooftop disconnect, great, goes down this dissipator right into the outlet. Same here. So this is a bioretention unit, which doesn't look great in and of itself. And then you can't really see, this is a valley gutter, and that is draining the rooftop. So parking lot sheet flows into the bioretention unit, but then the rooftop was supposed to go through the valley gutter into the bioretention unit, but instead it goes into a drain. So what I like to do is look at what's the plan? What's the plan to get the water in to the BMP, and what's the plan to get the water that's above the design storm out? And so in our example here, the water is going in at this location, and there's the rock, the dissipator to help with erosion, and then the water goes in and there's a retention, and then this is the outlet, and it connects into the city storm drain system here. And so that seems logical to me, right? Again, remember my first slide, one of my first slides, does it make sense? So this makes sense to me. And if this drain outlet was over here, that might not make sense to me. If it's at the right elevation, it might work. But I just kind of want to have a general understanding to make sure that these things are being thought about with this design. Same here. So this is the BMP, the second BMP. We have water in. Here is the drain outlet. Looking at the elevations, as long as it's not the lowest point in the bioretention, then, this should be an efficient BMP. So here's basically, what we're looking for is a drain outlet that is at a higher elevation than the bottom of the BMP. What happens when it's at the lowest point? It becomes problematic for a lot of reasons. And so, we have this BMP is clogged with debris, which is a whole different issue. But when it's at the lowest point, all the water is going to, essentially flow to that point, and it may not receive the treatment that it needs, and it's definitely not going to have the retention requirement that's needed. All right, so from there, I want to shift over to looking at, the standards, so that if whatever BMP is being provided in these plans, we want to make sure that we have a design standard to make sure that we have things like an overflow, high flow bypass, and that it's at the right elevations, and the engineered fill is being proposed, and the vegetation, right? And so a lot of municipalities have this, and they provide this to the design community to say, please include this standard in your plans. And, this is the standard you have to meet to build these BMPs. Sometimes we see design engineers use their own set of standards, but we need to have some reference to the standards that are going to be used. So I like to just make sure that the standard, if it's not the standard that is part of the municipality's LAD manual, then we probably want to make sure we look into the standards to make sure it meets the intent of your municipality's requirements. And I'm just going to skip through that. In this particular example, they didn't have a bioretention standard detail, so that was a note that I made. All right. I want to talk also about vegetation. I mentioned this earlier. I showed you the rock garden infiltration basin. When we're talking about bioretention, vegetation is a vital component. And I think this is still evolving. I think there are challenges for sure. And so I can see why someone in the design community might want to do a rock garden, because establishing vegetation can be challenging. And I know in California, we actually had some competing requirements with water conservation and establishing plants in bioretention. So there are elements of the vegetation part being hard to manage, and the amount of water you need to establish vegetation. What most bioretention standards say is that you need vegetation to be 51% covered in your bioretention BMP, and that there's usually specifications on the types of plants you have to use. They're likely going to be native plants. I know in California, we have a lot of drought tolerant plants, but it is a vital component. Here's some pictures. These are all bioretention BMPs by design, but they lack vegetation. Either they just didn't include vegetation as part of the install, or the vegetation wasn't well established and died. You can see this has, maybe you can't see, but there's a lot of invasive species up in this unit. And so this is the type of thing that we need to avoid. And so I think it's really important when we're reviewing LID to have some verification of the vegetation that is going to be installed. So I'm going to give you an example of why I think this breaks down. What I think happens in LID and why I go out to a project and I see all rocks and no vegetation is because the landscaping design or plans do not get submitted as part of the LID design. And I think it needs to be part of that. And so where I really see this occurring is, let's say plans go into planning and building, and then planning and building says, city engineer, here is your stormwater control plan to review for post-construction requirements. And the landscaping plan is still in the packet with the LID, or excuse me, with the other components of planning and buildings requirements, right? And so what I see often is what gets submitted to as part of LID or post-construction requirements is something kind of generic, right? And we see that in the cross-section, in the standard detail. It just says vegetative component. It doesn't specifically say what the landscaping plan is going to be on a design detail. So, we look at what's being proposed in LID, and it just says vegetation C landscape plan. And so then we go over to the landscape plan, and there's no landscaping. It's rocks. And, oh, by the way, they're going to put a filter fabric, which is going to prohibit potentially infiltration. And, in this particular case, the bioretention detail prohibits any kind of liner. And so this didn't go to the city engineer. So this is how the plan actually got installed, or the BMP got installed. And so it became so when you go out there and you're like, how did this happen? And I backtracked, and it's like, oh, there's a disconnect between the landscaping plan and the post-construction requirements. So I really recommend connecting those if you're responsible for plan review, because the vegetation is such a vital component. And I'll just make note that our local regulators are holding up termination of the construction general permit if bioretention is not installed correctly. So our regulators are actually going out to projects, and if they see these rock gardens with no vegetation, they will make you rip them up and put the vegetation in. And again, as I said before, we don't want to have these conversations when these BMPs are installed. we need to make some efforts to make sure we're looking at these things up front so we can address them during the design phase, not after construction. Okay, I'm almost done, so I have time for questions. So in this particular example, I was like, well, my question would be, what is the proposed vegetation? I want to know, how are you going to vegetate this so I can be confident that it's not just going to be rocks, that there's not going to be a liner, all these things that are vital to making sure that bioretention is installed to the design standard. I'm also going to make a mention about bark, and then I'm going to recap. Floatable bark is very problematic in bioretention or low impact development BMPs. I have had a project where the regulator saw that bark was installed and wanted it all pulled out, right? So after construction, it's all vegetated, it's all landscape, and the regulator said that's floatable bark. That's going to end up in the storm drain system and in the receiving water, and you have to pull it all out. So this is another component you want to be careful about, just verifying, what is going to go into a bioretention BMP and making sure that you're not going to be in this situation with the BMP failing at some point in the future. So again, I have lots more to say on this, and I because it's only an hour, I tried to kind of cram as much as I could in. So hopefully you've gotten some useful information that you can apply to your plan review in the future. So just to recap, I think the best thing you can do is use a checklist to determine if your project is complete. And, we're looking really, does your project meet your post-construction requirements, whatever those are, in that the treat and the retained stormwater runoff, do you have DMAs that are accounting for those drainage areas? Are we applying site design measure credits? And are we applying those appropriately? How is the water entering the bioretention unit? And how is the design storms larger than the required retention volume? How is that exiting the system? And then your bioretention details. We want these bioretention units installed according to those standards. And so making sure that that is part of the plan, especially the vegetation. So I did leave a few minutes for questions. So thank you for your attention.
Thank you, Colleen. We do have a couple of questions. The first one being, what if a retention basin has a riser for a higher storm event? Is that allowed, and does that make it a detention basin?
Yeah, I think that I see that a lot, right? So you have a requirement now to, okay, so you have to meet the 100-year flood. You have to detain the 100-year flood event so that you don't get flooding in wherever you're putting your project. But then you also have a retention component. So what I have seen where you try to just do one BMP is you have a detention basin that has a retention component. So it's not, so there's some level of infiltration, and that you have the engineered fill to be able to retain your, at least your design storm, right? And an engineer can look at what can be retained, what it takes to retain the required design storm versus the volume of water you need to hold during whatever storm event, 100-year event, to avoid the flooding. And then the difference could then be released back out into the environment. I hope that answers the question.
I believe it did. I think you have time for a couple more. From Stacy, what does the CGP require to be submitted for post-construction BMPs? Just plans for LIDs and calculations?
Okay, so in the state of California, the general construction permit does require post-construction requirements. And there's no bioretention requirement, not necessarily. You can actually use those credits, the site design measures I was talking about, as your compliance. Now, I'll say a few things. If the CGP project is in a municipal stormwater boundary, then the municipal stormwater's post-construction requirements will apply. Regardless, I think your question is, what do you have to submit as a part of your general construction, whether you're triggered through the permit itself or your municipal discretionary process. There is not a specific requirement in your notice of termination to submit post-construction implementation or compliance. Where I live, the local regulators do have an extra requirement. Well, they ask everyone to submit whatever their plan is and pictures of their post-construction BMPs as they're installed. And the CGP does say for the notice of termination that you do have to meet the post-construction requirements in order to receive your notice of termination. It's just the proof may vary. I'll say one last thing with the notice of termination. It's almost like an honor system thing, because you do have to say in your notice of termination, like, yes, we installed our post-construction accordingly. And so someone's certifying that. And so that's kind of it's that certification really, I guess, is the minimum requirement. And then you may have other things tacked on depending on your local jurisdiction.
Awesome. I think we have time for one more. Are oversized BMPs inherently a problem or just a red flag because they may indicate a deficiency elsewhere?
Okay, that's a really good question. And I neglected to address that in my presentation of why I thought that was a red flag. So I apologize. So remember when I showed you that C1 and C2 drainage areas, they were small drainage areas, but those actually didn't go to a BMP. So those drainage areas there was no treatment. And in that particular jurisdiction's requirements, you have to at least treat all impervious surface. So where the red flag comes in for oversized BMPs for retention is you might be able to say, okay, I have X amount of impervious surface and the 3 drainage management areas and 1 drainage management area, I can't do infiltration for whatever reason. So I'm going to double up somewhere else. Where at the end of the calculation, the volume you're supposed to retain is retained. But treatment doesn't work that way, because if you don't treat the water, you could double treat some water, but you're still letting pollutants off site. And so you've missed the requirement to treat all runoff from impervious surface. So that's the red flag, is you can oversize a BMP for retention, but you still need treatment BMPs for all drainage management areas, at least in most post-construction requirements. Thank you for asking that, because I neglected to close that loop.
All right. Well, thank you, Colleen, for a phenomenal workshop, and thank you for everybody for coming out and joining us for Stormwater Awareness Week. We still have quite a few workshops planned for today, so if you haven't registered for some of those, I definitely encourage you to go do so. I also encourage you to go and check out the keynotes this year. They're phenomenal as well.